Imagine you're monitoring the universe with some of the most advanced technology ever built. Everything appears normal. Distant galaxies glow faintly, stars are born and die, and black holes quietly shape the fabric of space. Then suddenly, your instruments detect a burst of radio energy so powerful that, for a brief moment, it outshines entire galaxies in that part of the radio spectrum. Before anyone can react, it's gone. The event lasts only a few thousandths of a second, leaving behind more questions than answers. At first, scientists thought it had to be a mistake. Maybe the telescope had malfunctioned. Perhaps it was interference from a satellite or a signal produced somewhere on Earth. Extraordinary discoveries require extraordinary evidence, and astronomers are trained to be skeptical. But then the impossible happened again. Different observatories, thousands of miles apart, began detecting similar bursts. They all appeared to be arriving from deep space. These mysterious events became one of the biggest scientific puzzles of the 21st century. They weren't just unusual. They challenged many assumptions about the extreme environments that exist across the universe. Some of these signals traveled for billions of years before finally reaching Earth, carrying information from a time when our planet looked completely different. The title of this video says, NASA detected a signal that shouldn't exist. While that phrase captures the mystery, the real story is even more fascinating. Scientists aren't saying the laws of physics have been broken. Instead, they're trying to understand what natural process could produce such incredibly powerful and unpredictable bursts of energy. Every new detection adds another clue, but it also creates new mysteries that researchers still can't fully explain. So what exactly did astronomers discover? Why are these signals unlike anything previously observed? And could solving this mystery completely change our understanding of the universe? Let's examine what the evidence actually tells us. Part 1. The discovery that changed modern astronomy. The story began unexpectedly. In 2007, astronomers were reviewing archived observations collected several years earlier by a large radio telescope in Australia. Hidden inside that data was a single, incredibly bright burst of radio waves lasting only a few milliseconds. Because it was discovered after the original observations had already been completed, researchers had to carefully investigate whether it represented a genuine event or simply an error in the data. Naturally, many scientists remained cautious. A single unexplained observation isn't enough to rewrite scientific understanding. There were many possible explanations. It could have been electronic interference, a problem with the telescope, or even a signal generated somewhere on Earth. Before announcing anything extraordinary, researchers spent years testing every possibility they could think of. Then something remarkable happened. Other radio telescopes around the world began detecting similar bursts. Observatories using completely different equipment, located on different continents, all recorded nearly identical events. That dramatically reduced the chance that these detections were simply technical errors. Scientists eventually gave these mysterious events a name: fast radio bursts, or FRBs. As more observations accumulated, researchers made another surprising discovery. By analyzing how the radio waves had traveled through space, they estimated that many of these signals originated billions of light years away. That meant these tiny flashes had crossed enormous distances before reaching Earth. The implications were astonishing. Even though an FRB lasts only a fraction of a second, it can release an extraordinary amount of energy in that brief instant. Whatever was producing these signals had to exist under some of the most extreme conditions in the universe. Instead of solving the mystery, every new observation made it even more intriguing. Scientists had confirmed that the signals were real, but they still had no definitive explanation for what was creating them. Part 2. Why these signals puzzle scientists. At first glance, radio signals from space may not sound unusual. The universe is filled with radio waves produced by stars, galaxies, planets, and clouds of gas. Radio astronomy has relied on these signals for decades to study objects that are invisible in ordinary light. Fast radio bursts are different because of their unusual combination of power, speed, and unpredictability. Each burst appears suddenly, releases an enormous amount of radio energy, and disappears almost instantly. Most are so brief that if scientists weren't constantly monitoring the sky with highly sensitive instruments, they would never know the event had occurred. Another mystery is that not all FRBs behave the same way. Some have only been detected once despite years of follow-up observations. Others repeat from the same location, sometimes after days, months, or even years. This suggests that there may be more than one type of object capable of producing these signals, or that the same object can behave in different ways depending on its environment. Researchers have proposed several scientifically supported ideas. One leading explanation involves magnetars, rare neutron stars with magnetic fields so powerful that they can produce violent bursts of energy. Another possibility is that some FRBs are linked to collisions involving extremely dense stellar remnants or other energetic cosmic events. However, none of these hypotheses explains every observation. Some bursts fit the magnetar model well, while others appear to originate from environments that don't match those expectations. That's why astronomers continue collecting data rather than declaring the mystery solved. In science, unanswered questions aren't failures, they're opportunities. Every unexplained signal encourages researchers to build better telescopes, gather more evidence, and refine their understanding of how the universe works. Part 3. How NASA and modern telescopes are solving the mystery. Although NASA is widely associated with space exploration, solving the mystery of fast radio bursts requires a global scientific effort. NASA works alongside observatories and research institutions around the world, combining information from space-based missions and powerful radio telescopes on Earth. Every new observation provides another piece of a puzzle that scientists have been trying to solve for years. Modern radio observatories can now scan enormous portions of the sky continuously, increasing the chances of detecting these incredibly brief events. Once an FRB is detected, astronomers quickly alert other telescopes operating in radio, visible, infrared, and X-ray wavelengths. This coordinated response allows scientists to gather as much information as possible before any related activity fades away. One of the biggest breakthroughs came when researchers successfully traced several repeating FRBs back to their home galaxies. Instead of simply knowing that the signals came from deep space, astronomers could finally identify the environments where they originated. Surprisingly, not all repeating bursts came from the same type of galaxy. Some were linked to regions filled with young, active stars, while others appeared in much older galaxies where scientists hadn't expected such energetic events. These discoveries suggest that fast radio bursts may not have a single universal source. Different cosmic environments could produce similar signals through different physical processes. That possibility has made the mystery even more exciting, because solving it could reveal entirely new aspects of stellar evolution, magnetic fields, and the behavior of matter under extreme conditions. While scientists have made tremendous progress, many questions remain unanswered. Each new detection helps narrow the possibilities, bringing researchers closer to understanding one of the universe's most fascinating mysteries. Rather than proving something impossible exists, these signals remind us that the universe still holds many secrets waiting to be explored. Part 5. Could these signals reveal hidden secrets of the universe? While the source of fast radio bursts remains an active area of research, scientists have discovered that these mysterious signals are valuable for another reason. They can act as natural probes of the universe itself. As an FRB travels across billions of light years, it doesn't move through empty space. It passes through clouds of gas, magnetic fields, and diffuse matter spread between galaxies. Every region it crosses slightly changes the signal before it finally reaches Earth. By carefully analyzing those tiny changes, astronomers can learn about parts of the universe that are otherwise almost impossible to observe directly. One of the biggest mysteries in cosmology involves what researchers call the missing ordinary matter problem. According to calculations, a significant amount of normal matter should exist throughout the universe. Yet much of it has been difficult to detect with conventional observations. Fast radio bursts are helping scientists trace this hidden material because the radio waves interact with it during their long journey through space. In other words, these signals are more than unexplained flashes. They're powerful scientific tools. Every new detection helps researchers map the invisible structure of the cosmos, study magnetic fields between galaxies, and better understand how matter is distributed across immense distances. Some headlines have suggested that these signals could be evidence of alien civilizations. While that idea often captures public imagination, there is currently no scientific evidence supporting that conclusion. Astronomers continue to investigate natural explanations, because those are strongly supported by the observations collected so far. Science advances by testing ideas against evidence, not by jumping to extraordinary conclusions. That's why researchers remain careful. The true value of fast radio bursts isn't that they prove something impossible. It's that they offer a new way to explore a universe that still contains many unanswered questions. The universe has always challenged human understanding. Every generation has encountered discoveries that seemed impossible at first, only to become part of our scientific knowledge through careful observation and investigation. Fast radio bursts may represent another chapter in that ongoing journey. Today, scientists know these signals are real. They know they originate from distant regions of the universe. They know they release enormous amounts of energy in an incredibly short time. Yet despite remarkable advances in technology and years of research, many questions remain unanswered. Are all FRBs produced by magnetars? Or are there multiple types of cosmic events responsible? Why do some repeat while others never appear again? And what other secrets might these signals reveal about the invisible matter spread across the universe? Rather than viewing these unanswered questions as mysteries beyond explanation, scientists see them as opportunities for discovery. Every new telescope, every improved instrument, and every additional detection brings researchers one step closer to understanding the true nature of these extraordinary cosmic events. Perhaps the most exciting part of this story is that the next breakthrough could happen at any time. Somewhere in the vastness of space, another powerful burst of radio energy may already be racing toward Earth, carrying information that has traveled for billions of years. When it finally arrives, it could provide the clue scientists have been searching for, or reveal an entirely new mystery that no one has imagined yet. That's what makes astronomy so fascinating. The universe is constantly reminding us that there is still so much left to learn. If you enjoyed exploring this incredible scientific mystery, don't forget to like this video, subscribe to Earth Enigma, and join us as we uncover more of the world's and the universe's most fascinating mysteries. Until next time, keep looking up because the next great discovery may already be on its way.